Hey everybody, welcome to lesson 9.2. Inside of this lesson, we're going to be using the Pythagorean theorem again to find the length of one of the legs on our right triangle. So as a refresher, here was our Pythagorean theorem we wrote down and worked on yesterday. So make sure you definitely have that in your notes. We're using that this whole chapter. Let's go ahead and look at some problems. So here we have our problem, our right triangle, and we see the hypotenuse, which is opposite the right angle, is always the longest side, so that's our 26 feet. And then the legs are the two short sides. The legs are always connected to the right angle. So here we have y and 24 feet. So what we're going to do is set up our Pythagorean theorem with our two legs squared added together, equaling the hypotenuse squared. So here's my formula. A squared plus b squared equals c squared. I know my first leg is 24, but now my other leg, I don't know the answer. I don't know it, so I'm going to call it y as it's labeled here. So I have y squared equals 26 squared. And then what I'm going to do is go ahead and square 24. I'll show that on the calculator here so I can hit 24 squared. Squaring key is here above log. I get 576. And 26 squared is 676. And then what we want to do is solve this for y. So to get y by itself, we need to get rid of this plus 576. So what we're going to do is subtract 576 from both sides. I'll make it just a little bit larger here. So I'll subtract 576 from both sides. 676 minus 576, that's convenient. That equals 100. And we end up with y squared equals 100. So now we're looking for what multiplied by itself gives us 100. So we can think about what numbers multiplied by themselves, like 5 times 5, 25, 6 times 6, 36. And hopefully we know 10 times 10 is 100. So y will be 10. And if you can't think about that just quickly off the top of your head, you can take the opposite of squaring, which is the square root. And the square root of 100, to do that on our calculator, the square root button is here. It's in the blue ink right above x squared. So we hit second to activate the secondary features and hit the squared button to get the square root. Then we can type in whatever we want to take the square root of. So there we go. We get 10. And just to show you how that works, 10 times 10 takes us back to 100. So the square root of 100 is 10. So there's our first one. Y is 10. And we could go ahead and label this 10, and we could also check it. We could see if this works. We could take 10 squared plus 24 squared and see if we get 26 squared. And you'll find out that it works. So I'll let the teacher pause the video, and the students can write down that example and ask questions. Then here's our next problem we're looking at. We have another right triangle with 4.3 centimeters, x, and 11 centimeters. So we identify the legs, we identify the hypotenuse, and we're going to go ahead and do the exact same thing. So I challenge you to try this on your own and then to come back and to look over the answers. So we're going to plug in what we know. X stays as x, so that's x squared, plus 4.3 squared equals the hypotenuse squared, 11 squared. 4.3 squared is a little bit messy. We definitely need to use the calculator for that one. So 4.3 squared, 18.49. And 11 squared, that's 11 times 11, 121. And we're going to go ahead and solve this just like our last one. We're going to subtract that 18.49, and then we get x squared equals 102.51. And then we take the square root. So I'll show once again how to do the square root. We had second x squared, and it was what, 102.51 if I remember that correctly. We get 10.12. And there we go. And we use this, it's not an equal sign, but it's going to be the approximation sign. All right, I'll continue this on video 2, the last two examples.